Okay, let's go. Let's do some fun maths. Yay! Fun, fun maths. Yay! Does anyone have any questions from?
Sorry. The name is written because Morgan Wallen said it, and now they're like, we got you, Morgan Wallen.
Who's Morgan Wallen?
He's a country artist.
Ew. Okay, never mind. I don't care.
No, I don't listen to country. I just saw it on my.
Okay.
Why is that on your For You page?
It's sort of
It
sus.
was somebody
That
bashing
means you
them.
like it.
No, it was somebody bashing them.
Because it goes from 58 to 50.
Well, anyone got a question that you encountered yesterday?
Math and math.
8B. Thanks,
Yeah.
Kate.
8B.
You
that
are
the one
an
that I gave?
integral.
Oh.
Get it? Member of this class. Yes.
Did you actually just answer the please?
Certainly, you are also an integral member of this class. Get it? Integral. You get it,
Yes.
guys? Do you understand? Emily, did you understand that word
get the
just
joke?
integral there? It was very funny. Appreciate my joke.
What are you doing?
Okay. So, you have a velocity function. You guys know what I like to do when I see a function like this. Hopefully, you know, graph. I like to graph it.
That's fair.
And I'm just focused on the interval from 0 to 5 because I look forward to the question to see, like, okay, we're talking about going from 0 to 5. So to graph this, I should vector it. Okay. And when you factor it, it gives you nice information about the roots 0 and 4. And is this a frowny parabola or a happy parabola?
Brownie.
Frowny. So we know the shape has to look like this. That make sense to everyone? Yes?
Yep.
Not like it's that critical, but maybe it will be critical. I'm not sure actually. But at time 5, what's the velocity at time 5? Okay. Anyway, what's the average velocity from time 0 to time 5? So the idea would be what's he doing between time 0 and time 4? He's moving in what direction? Right, moving to the right. And then between time 4 and time 5, he's moving to the left. Okay? So his average velocity, okay. This one's for you, Jesse, if you're watching. That's Jesse's favorite. She's trying to trigger me. Okay, so the average velocity would be the integral of the velocity function between 0 and 5 divided by the total time, which is 5. So this integral, let's see, let's integrate that. It's going to be integral of him is 6t squared minus t cubed. No chatting, please. All right. Everyone's fine with that? Make sense? Okay, let's plugging in the 0 is going to be very easy. That's nice. Plug in the 5, a little bit less easy, but 6 25s, 150. Maybe in the margin you go 150 minus 5 cubed is 125. So it turns out that this is going to be 25 minus 0, all divided by 5. And look at that, you just get 5 meters per second is our average velocity. So what's the significance of this number? Or sorry, just 25 in general. What's the significance of 25? It's one word.
That's the total displacement.
The displacement, yep. So if he had started at position, say 0, he'd be at 25. If he had started at position 1,000, he'd be at 1,025. Make sense? Okay. So for B, and I'm sorry, I probably should have given you more room for B than for A. That's my bad. Because there's two parts to it. Firstly, what's the integral? So say you're doing this as a computer-assisted problem. Can you do this in one integral that just does it all? That we calculate the total, the average speed. Because what is speed? Savage is just the total distance covered divided by the time. And so, well, how do you calculate distance? It's the integral of the absolute value of the velocity. And then you divide that by total time. Is everyone okay with that? That idea? Does it also make sense why if you took the absolute value of this function, it would look like this. And this area would get transformed into positive area. So all of my displacement would get counted as positive in my calculation. You okay about that? By the way, before we do any calculation, is the answer going to be bigger than 5 or less than 5? Bigger. Because we're just, with this 25, took this positive area and then subtracted this area. This was a negative area. So it went, ended up at 25, but that means that this must be quite a bit bigger than 25, right? And so when this area turns positive, it's gonna, when you treat all that area as positive, it's gonna be a lot bigger than 25. Okay, let's calculate it. Are we ready, spaghetti? It's bigger. Yeah. So to actually calculate this by hand, what you'd want to do, you need two integrals. I think that was in the hint, wasn't it? It said split it up into two. Yeah. So think graphically, there's our graph. So what you would do is you do first find the area between 0 and 4 of this. And then add on. Now this is where it gets gotta be a little tricky here. Does it make sense how if you did the opposite of this function, it would produce a positive number? So here, let me show you what I'm getting at here. Here, tell me if this makes sense. This is one way to write it. Because if you just integrate the velocity function from 4 to 5, it's going to produce a negative number. So if you subtract that negative number, then it'll effectively be turned positive. Does that make sense? Or if that confuses you, another perspective is just to do this. I think a lot of people actually like this better. They say, well, do I really need to kind of do it all at once? Or couldn't I just find this area, and then just make sure they're both positive numbers and then add them together? So let's do it that way. Okay, integral again was 6t squared minus t cubed, but this time we're going from 0 to 4. Okay, this one's a little bit more of a pain in the bottom, but so you end up with 6 times 16 minus 4 cubed minus 0. Plugging in 0 is easy, right? And so you get here 60 plus 36, 96 minus 64 is what, 32? So here, this will help you assess your own understanding here. Do you see on the picture where the 32 lives? where his home is? Where's his home?
From 0 to 4.
The Biodome, starring Pauly Shore. You guys can see that movie. This. That area right there is 32. So
So do we even have to take the integral of the other one, or can we just know that that plus the other one is 25?
I guess at this point you could infer that this had to have been -7, thus this is +7. That's thinking pretty. That's some pretty slick thinking there.
I like that thinking.
And you guys hear what he's get that? So we know the answer is going to be then 39. So in the interest of showing our work, though, you can certainly write a sentence that says, okay, we just said, like, you can reason out that that area has to be 7. But I don't know. It's actually one thing you certainly, in any case, what you're going to do is reuse your arithmetic, where you go, well, I know that plugging in 5 earlier got me 25. I know that plugging in 4 gets me 32. And so there's your -7. And so then all you got to do is go, okay, I guess my average speed then is 32 plus 7. Treat that 7 as positive, divided by 5. That's 7.8, I think. Because 40 over 5 is 8, so yeah, you're a fifth away. I think that's right.
Yeah.
You can write 39 fifths if you want. Yay! Yes, Rafe?
Trying to figure out what my question is.
Okay.
I think it's fine.
Does it not sit well that this average speed is bigger than the average velocity? 'Cause that confuses people sometimes.
No, it makes sense that it's more, it's just, when we flipped it over, I don't see where we're getting 32, I guess.
The 32 is just through calculation purely.
Yeah. I think it's fine.
So yeah, 32, I had no idea what the 32, as far as like, there's no nice, simple way to be like, oh yeah, there's gonna be a 32 there. We had to just purely crunch that out. We crunch the numbers. Are you wondering why it's a 14-point swing between 25 and 39? And 14 is double the 7? That's another one that's, Laura, you got a question?
Yeah, so I'm kind of wondering why you chose 5, like where's the 5?
Where? The 5
Yeah.
here?
Yeah.
That's just because the question happens to be asking us
Okay.
about going from 0 to 5. If the question had said, go from 0 to 10, we would have set our upper bound as 10.
So like, is the 4 and 5, is that evaluated because that's where it's negative?
Yeah, so the 5 was from the problem. The problem prompted us to investigate going from 0 to 5. The 4 is relevant because that's where the function hits 0. We do that by factoring it. And so if you tell the story of this particle, it looks like this. We don't know where it started, but the particle or the person or whatever, basically between times, so here he's at time 0. He ran 32 meters. And what did he do when he hit 32 meters? He was at 0 velocity. So he turned around and ran backward 7 meters and he landed at position 25. So he went, is this making any sense, or is this, I don't want to belabor the point, but he went 32 meters, that's represented by this area, and then he went backward 7 meters, that's represented by this negative area. And so if you're looking at his displacement, okay, his displacement is 25, but his total distance is 32 plus 7, 39, so when you divide those by 5. Yeah? Okay. Any others? No?
I guess, Paul, quick question. On 3, can you just simplify that straight away? Like, because it's an x squared plus 9. Are you allowed to do that? No.
Can you turn the x squared plus 9 into x plus 3? That one you gotta do, you basically got a u prime times u to the 1/2 there.
Okay, that's
And you're gonna need to introduce a 2, because your u prime needs to be 2x. You gotta introduce a 2 inside the integral, put a 1/2 outside the integral. Did we ever get consensus on the answer to 3? Did you? I know you guys were.
Yes, yes, we did.
We found consensus.
Do you want to go over? I don't know. Let's go. Let's do at least one more shade of the region area finding, just as another example for the millions of Twitch fans out there. What do we think? Should we look at? We could look at 15. Looks pretty nice. Maybe 14. Maybe.
Anyone?
Any of them? I'm trying to find one that's really lit.
Oh, my arithmetic was just wrong. I figured it out.
You what?
I figured out the equation. My arithmetic was just wrong.
Wow. Okay, let's just do like 17? Sure, we'll do 17. And then I do want to go over maybe like one of these weirder ones down a little bit later, as you probably said. But yeah, let's do.
There.
It's Thursday today.
Yay.
Okay, so 17. That has an absolute value in it. That's scary.
No.
Scary, Trenton.
Not
So what are we
scary.
gonna do when we see an absolute value? Think
Graph.
graphically. So where do these guys cross?
At 2 negative 2.
Yeah, they cross at
I knew
2
that.
and -2 on the x-axis. So that's actually pretty nice and convenient for us. Does that make sense? Those are pretty easy looking graphs, I think. So we got to do parabola minus doodad here. Now let's think. Are you okay? You fine? All right. So I'll show you two approaches. I think I know in advance through psychic powers which one you guys will like better. But you could do it like this. You could say this is -2. This is 2. So I could go because we can't integrate. We don't have like a rule for the integral of absolute value of x.
Oh.
We kind of do. The integral of absolute value of x is a piecewise function, which is going to be annoying to deal with. So you certainly could do it that way, but that's typically you do this. You'd say, oh, I'm going to go from -2 to 0, and you got to go top minus bottom. So you go 4 minus x squared minus, what's the equation of this curve? Just the left part of it. -x minus 2. Does everyone understand that? Don't copy this down so quickly, though. I'm making a point here. I got a moral. This is like that one guy who had those stories. You feel me?
Aesop?
Aesop. He had the moral, right? Don't
Yeah.
cry wolf. Was that him?
I think so.
Don't
Yeah.
Don't blow down the houses. Don't build a house or something. Remember that one? The
Don't
pigs.
build a
The
house.
pigs. Don't build a house. That's what he said.
Don't kill your golden egg.
There you go. Don't kill a goose. Good. These are all good things to know. Now that's valid. That's gonna work, right?
Yeah.
That's gonna work.
Sure
But man, that's a lot.
will. Sure is.
Who's figured it out? Who knows what we're gonna do instead? Yes, right.
You're just gonna find the area of the triangle and do the one with the parabola.
Oh, you could do that.
Oh,
Yeah.
that's what I was
That's a good
thinking.
idea. Yeah. I didn't think about that. That would certainly work. This is just a triangle, so you could just take this area and then add on the triangle. But the other way to do it, I do like that idea.
I'm partial.
But just to illustrate the point here,
It too.
I'm
I
just
thought
going to
that was
take
really
this
cool.
integral,
I thought that idea was really
and
cool.
do you see
Rick.
how this integral, it's a symmetrical shape, right? So I can just find the integral from 0 to 2
Oh.
and then double it. But honestly, though, I mean, give Ray credit. I think his answer is actually easier because you don't have to. I mean, they're both going to end up being pretty easy at this point.
Does it
So
matter which integral you do? Or just do?
no, you could have done that one.
Okay.
Yeah, you could have done that one instead. So instead, this reads. Let's simplify it first. 4 minus -2 is 6. Then we got a minus x and a minus x squared. And so, whack. So if you're, what Ray was saying is you basically just do the integral of 4 minus x squared, right? Get that area and then add on. This is 4 times 2 divided by 2, so it's 4. But anyway, they both work. So here you're gonna get 6x minus half of x squared minus a third of x cubed. You're gonna plug in, now we feel good because plugging in 0 is easy peasy here, right? So it's gonna be, let's see, plug in that 2, you get 12 minus 2 minus 8/3. Then you plug in the 0, you get nothing. And so you get 10, which is 30/3, minus 8/3, 22/3. So the answer is 44/3. It's a nice number, isn't it?
No.
Yeah, it is. What up?
Where'd you get the 6 from? Or?
4 minus -2.
Paul, is there a formula that would be able to find like any parabolic like shape like that? Is there like some formula that you could do for the area of that?
What, given the roots? In the area between the roots? Is that what you mean?
Maybe. Yeah.
Probably. I don't know. I mean, yeah, you could derive one pretty easily, I think. Because,
We do like a constant.
well, a lot of it just, yeah, it's going to depend on, what kind of shape it is.
Well, yeah, it'd be
Here's
like,
a dish.
I mean, like for square, it's based on height. So what would it be for like a parabolic function that's like cut off with like a straight line?
Well, so one issue, okay, so say you want just the simplest, that's in quotations, simplest parabola that say crosses at some value A and some value B, and then you just want this area. Now, when I say simplest, I mean assume that this has the form of x minus A times x minus B. And you could integrate that using A and B as constants and get a formula for the area. But the problem you run into is there's an infinite number of parabolas that cross A and B. Right? I missed. Get
Yeah, I
that?
assumed height would be a portion of it.
Oh, so then, yeah, I'm trying to think. That would be, yeah, you could do that. You could have this, and then you define this height like that.
Yeah.
I don't know a formula off the top of my head, but I'm sure you could derive one because 3 points is sufficient to define a parabola. because the parabola has three coefficients, so three points would define.
Couldn't you just do it with one if it's symmetrical?
Do what?
If it's just a basic parabola, couldn't you just do it with 2 points? Because no matter where.
If one's the vertex, yeah.
Yeah. So one
Yeah, if you
vertex
know
and
the
one side.
vertex. Yeah, so if you know the vertex and you know one of the roots, yeah, you could derive a formula, I think. You'd have to then show yeah, it's an interesting problem. I would discuss it with you later if you want. I mean, I think it might it'd be interesting to see if you end up with a nice elegant formula, because the procedure that I'm thinking of would be just a little like arduous, because you have to go, what is the general formula for this parabola? And then you'd integrate it, plug in the bounds, and then maybe you get some nice closed form at the end. I don't know. We can check it out in a few minutes when we're done with these exciting problems, Kate,
Woohoo.
right? Try to contain your excitement if you can. Okay, I want to go over one last thing. Remind me, Rafe. We can discuss that in a second. It's an interesting question. I wanted to look at. Bear with me for a second here. Something like 28.
Okay. How about we do 28?
Oh no, 26. Sorry, 26 is much easier. 26. This might upset you. Fair warning. Trying to trigger us. Trying to trigger you. Ugh. Okay. I just realized, Rafe, you know what you're gonna do is you'll just put it like this, and then you get to flex, and everyone can say, that's a good math flex. Assume without loss of generality that it's centered on the y-axis, and then you proceed from there. And you just get a flex. You get to flex your cool acronym, whatever you want. Right.
I don't get it.
You assume, so because the parabola can be shifted anywhere, so you derive the formula here, because Rafe's talking about, suppose I know the height and the width
Yeah.
of this figure, and then from there you can shift it wherever you want, and it'll still
Okay.
principle work. So that's what it means to assume without loss
see.
of generality. The generality meaning I can put it wherever I want. Anyway, so 26, bruh, what shapies are those?
We got
What is that? Did I say 26 or 28? I meant 26.
It's a parabola on the side and so on.
Yeah. So you need to. This understanding these questions involves sort of a mental process of basically turning your head, looking at things sideways. Okay. Because this describes a sideways parabola. So we need to first make sure there's no confusion on that.
This is another situation where you could just use the basic formula.
Right.
Driving a little bit.
Yeah. Right. You can drive one. Yeah.
Wait, why is it?
Or just use one.
So yeah, why is this? Well, we need to understand this. Why is this the case? Okay. Well, because remember, an equation describes a family of points, right, that fulfill a certain relationship. So if you were like making a table of values, for example, of what kind of points live on this curve, just start kind of throwing points out. Okay, 0, 0 makes that true, right? How about when x is, say, 1? Y has to be 1. But wait a second, couldn't y also be -1 and x could still be 1? So that tells me that when x could be either one of those numbers and get those two different, or sorry, I said that wrong. If x is 1, y could be either one of those numbers. So that's giving you, say, like there's 1, 1, and there's 1, -1. Repeat the logic for like, how about if y was 2? Well, x has to be 4. How about if y is -2? Well, y has to be 4. So there's 4, 2. There's 4, -2. Is this making sense? Okay. Then it says, well, Now forget where I put those dots, because I'm just gonna call this, x equals 9 now.
Oh.
Not to scale. Right? So do we see the area bounded up by the curves? Like this. Do you feel okay about that?
Yes.
Okay. So there's a few ways you could do this. I want to show you 3 equivalent ways to do it. Okay, you don't have to write them all down. I'm just going to show them to you. One way to do it, and this just so happens to work because this is so nice, and it's a very simple shape. This method I'm about to show you probably is not going to work. For example, if this was a diagonal line, it's not going to work. But just throwing it out there, what someone might do is go, well, this curve I could describe as y equals the square root of x, right? I could rearrange the equation and then do this integral. I go integral from 0 to 9, right? Because that's my x values, of root x minus negative root x. Does that make sense? We sure that makes sense?
Or can you just do 2 multiplied by?
Right, which is identical to saying, okay, it's the integral of 2 root x dx. Okay, I'm not going to calculate it yet. We're starting to move into this realm of calculation where sometimes we don't really care what the number is. We're just more caring about like showing how these 2 integrals are equivalent, because that's kind of where the tasty nougats are of information. So that would describe that area. Are we all fine with that? Okay, notice, why did I put a 2? Oh, bro, I was just testing you, obviously. That's supposed to be a 9. SMH in my head. Okay, but keep in mind, what kind of values were those? X values with x's, okay? So what we're gonna do now is shift our head over and go, what if I wanted to integrate with respect to y instead? So what y value is this? If this is 9, negative 3, this is 3. So now, again, what we got to do, take your head. All right? Stop me. This is probably going to confuse a lot of people. So I definitely want to make sure there's no confusion. But I'm going to go from negative 3 to 3. And my integral is all going to be in terms of y values now. Okay? I'm sorry, I meant to say, sorry, I said that wrong. What I want to do is go, well, from this perspective here, what's this? What's the height? 9. Minus, and then what are these values? Well, y squared. Notice that this distance here is the difference between the x values. Okay? And again, these are y values, so all my integral is going to be in terms of y's. How do we feel about that? It's not easy. It's something that's notoriously confusing. What's up?
So would you think about it all positive and you would just not count that part below the x-axis as negative then?
Correct. Because with this, calculus has a lot of like context dependent stuff. The way this question is framed, it's what's the area of this bounded region? So in that context, all area is considered to be positive. Okay. Last thing. Here's the other way you could do it. You can go, wait a second. All these symbols are just arbitrary choices of little dashes and stuff, right? Dots and dashes. So what's to stop me from just turning my head and pretending like this is the x-axis and this is the y-axis? What's to stop me from doing that? What's to stop me from just going like, and you gotta be careful with this. This method I just showed you, this is gonna be the easiest way to do it. So just giving you a heads up. This is the way that I really want you to learn it. But I'm just saying in this case, what you could do is rotate the whole picture and just kind of change your coordinates right? And say, well, you say, wait a second, if I just rotate this whole system, then I've done the problem before, right? We did this problem earlier. I could just go the integral from -3 to 3 of 9 minus x squared dx. But the thing is, I mean, is that really any different from just doing that and then saying, oh, I'm going to go the integral from -3 to 3 of 9 minus apple squared d apple? Right? Is that really any different? No. So, I guess the point I'm trying to make here is when you do this, you really are doing this. You really are rotating the system and changing the variables. But I don't know. Have I confused the heck out of you? Or does this make sense? We're out of time. I wanted to go over 27 and 28 follow. Actually, from there, I think it's the rest of the problem set kind of continues with this theme. So try to do one or two of those problems on your own and see if you understand the whole change of variables thing. All right. Yay.